Actually, nice little connection here, I guess. So just kind of pay attention here, the relationship between solving an equation and the graph. We will jump to the graphing calculator, but this first one's actually pretty easy. What is the answer, by the way? 3 to what power equals 9? Okay, so the teacher that made this, Mr. Wilson, knew this year, said let's do like a connection between simple solutions and what happens in the graph. And what we talked about in the graph, I'm trying to get my colors right. I think on my graphing calculator, the first graph is blue, the second one is red, but we're not going to the graphing calculator. Okay, to solve this through graphing, all we need to do is find the intersection of these two sides. All right, so that's kind of the connection he wanted to have happen. First of all, y equals 9 is what kind of line? Red, straight, wrong. I mean, true, all lines are straight. So it's linear. Someone said it's linear. That's the line. What kind of line is it? Horizontal. Don't yell at me. All right. So y equals 9. So there's the y2 graph. Okay, that's what you would see. And the expectation when we go to the graphing calculator, knowing our windows, we'll talk about that later when it's off the screen. This one's not, though, if you do Zoom Standard. And then input, say it. What's 3 to the 0 power? 1. So I plug in 0, I get 1. What's 3 to the first power? 3. This was our, I don't know if it was our first input. No, not even close. We chapter AP in the beginning in August. I started input outputting right away. Then here we go. What's 3 squared, everybody? 9. And then that's where we see the intersection. And then remembering, this is why another good thing by Mr. Wilson. You need to remember your basics of graphing of an exponent. You know, that there's a horizontal asymptote because when I put negatives in for x, I get 1/3, 1/9, 1/27. This gets closer and closer to 0 as you put negative values in for x. But that's not really what we're doing here. What we're doing is solving, and the intersection of those two happens at 2. So it's a verification of that happening there. All right, next one. Hey, what's x equal? This is pretty simple. Just think about it and then tell me. 3, 2, 1, go. 3. Is you just change the logarithm to an exponent and you get 3 to the first equals x. I don't know what else to tell you there. Okay, but then just reminders of graphing. I'm not going to use the graphing calculator yet because you're supposed to know this without. We'll put this in y2, which is y equals 1, horizontal line. And then this is, okay, so I'm going to put this in y1, or I'm just going to graph it. Let me just start with this. What happens when I plug in 0? What's log base 3 of 0? What's log base 3 of 0? Undefined, that was where we found the vertical asymptote. So the knowledge that a logarithm has a vertical is very massively important. And I can't plug in negatives. I can't plug in -3 for x. That doesn't evaluate. But I can plug in 1. What's log base 3 of 1? 3 to what power equals 1? What's the answer to that? 0. Then the next one I'd plug in is 3. Okay, what's log base 3 of 3? So I plugged in 3 and I got 1. Boom shakalaka. So that is why this graph looks like this. Probably should have done a little bit better at 9. I should have got 2 because 3 squared equals 9. Right, so 9. That I could have added that point, what you were expected to do back in the day. Okay, but then there you go. You have that intersection at 3. I missed that. So that's why x equals 3 as well. That's what happens with input-output graphically. Now I think we're going to get to the graphing calculator, but let's solve it algebraically first. What do you do first? Hurry up. Subtract 3. And then this is why we're going to go to the graphing calculator. The next thing is change the log. Change the exponent to a log. Had log in my head there. And then add 1. And then in the spirit of the quiz this is how on the multiple choice that answer will be written when you have to choose a selection. So it's completely no scientific calculator. We'll give you a basic if you're having troubles with your times tables. Anyway, And then that's a decimal. So actually I have to go to the calculator first and get that decimal just to see what I get. So second quit. And then you can see that here. And often I do this. Watch, watch, watch. I never use that cheating button. Never. I call it a cheating button because I don't know. So I just do this. Log 7, enter, divided. But notice I didn't close the parentheses because I already evaluated the decimal for whatever log 7 is. I got that. Then I have to add 1. Then add 1. No, sorry. Log 7, my bad, dogs. Divided by log 2. Okay, I didn't finish that change of base formula. So that is the change of base, but done a lot faster typing wise, as opposed to trying to find this button. And I will tell you during a test, I'm not helping anyone on their calculator. A, I'm a jerk. Well, I already know that. B, it's your turn to tell me that you know what you're doing. That's a test. Okay, once I help you on the test, I should put my name on it. Then it becomes my grade, not yours. Oh, he's so mean. I don't care. Okay, these students have to have responsibility. And then what did I have to do next? Add what? Just like plugging in their Chromebooks, right? Not having to use my electricity in here, right? Poor Mr. Samuel's got to pay the bills for these people that can't do. All right, I'm done. Enter. 3.807. 3.807. 3.807. Okay, now we are going to go to the graphing calculator and do this in Y1, this in Y2, and then see the intersection. I mean, I can kind of start it. I know it's Y equals 5. And then I know it's up 3. So I guess I will do this. Up 3. I didn't do this in first hour because I knew I had a decimal. So I just went right to the calculator. But input, say it. The point you're going to plug in is 1. 1 minus 1 is 0. What's 2 to the 0 power? 1. What's 1 plus 3? 4, Mr. Samuelus. Okay, so I plugged in 1 and I got 4. Now, after this, you have 2 to a power, so you can expect like this graph. 1, 2. Yeah, I'm actually a little thrown off here. So plug in 1, and then I get 4. All right. I don't know. Something seems wrong here because the intersection is supposed to be at 3.07. That seems a little too flat for me. 3, 2 squared is 4. 4 plus 3 is 7. Huh. I don't know. Something's bothering me. So right 1, 1, up 3, whatever. 1, 2, 3. We'll see the intersection on this graphing calculator. All right. And then let me slide this over so I can see it, or I'll go over here and open up the calculator. So feel a little weird, but let's just see. Y equals, did I do something wrong? What did I do? You know what? Gosh dog it. Gosh dog it. Sorry for my language. This just happened last hour and I just saw that. So that's a typo. That's what's wrong. So I knew something was not connecting between what the answer is and what happened here graphically. So that's at Y equals 10. So then I could plug in like 3. 3 minus 2, 3 minus 1 is 2. 2 squared is 4. So 3, 1, 2, 3, comma 7. That's what I was expecting. I knew something was wrong. Thanks. And then it's going to hit somewhere like that. So I can't do that without a graphing calculator. I can't make a guess. So that's why we need that. All right, good. Thank you for catching that. Okay, and then, of course. All right. Every day. All right, so Y equals clear and clear. All right, so I can do this. I can. 2 caret X, sorry for the small calculator screen, but we got to see these equations. All right, plus 3, and then someone about ready to pass out. Huge yawn. Okay, and then I want to go ahead and zoom this out so I could see. And I probably should have adjusted my window a little bit. But Y equals 10 is right on the edge of zoom standard. So zoom standard, just teaching this as if you've never touched your calculator before. And then second trace, that's calculate. and then intersect. And remember, hit enter 1, 2, 3 times. And then you see that intersect 3.807. All right. So the connection between algebra and graphing and how graphing can actually help you solve as well. All right. So that one, oh my gosh, I just love it. Okay, now I will tell you this again on the calculator. Sorry, no calculator, basic calculator, multiple choice. This is how you're going to do this question. Divide by 2. And then what's ln? Log base what? E. A couple people answering, so it proves they're listening. If you're not, all right. Log base e squared equals x plus 5. So x equals, this is what you'll see as one of your answers. And it actually saves you time. You couldn't get the right decimal anyway if you couldn't get this to this point and then go to the calculator and type. So there should be no complaints about leaving this in calculator ready form. None. All right, but then to see this graphically, I probably do want to get that decimal. So second quit. The e to the power button's here, and it was e squared. Was it plus or minus 5? Plus or minus? Minus? Minus 5? Good. Thank you. 2.389. 2.389. So I need that though to 2. Was it 389? I already 389 or 839? 389? 389. I want to do some dyslexia there. All right. And then on the graphing calculator, I don't need to show a sketch of it. 2ln x plus 5. So y equals clear. I don't think I have to keep doing this. You get the point, I hope, at this point. 2ln. I do want to show something else for those that have TI-83s on the next log. I'm sorry, what was it on the right side? 4. Okay, that's how long it took for them to answer that. Boom. Hey, something to mention. Does that graph end right there? Is that it? Does that graph stop? No, that's the pixels. Anyone know what pixels are? TVs have like, I don't know what they have right now. They're like almost thousands, if not millions of pixels. That way your screen is so nice when you watch TV at home. Your pixels on your phone are pretty good. The pixels on a graphing calculator, not so much. So the graph just kind of can't be created anymore by the limitations of the screen. So you have to know that I didn't say this. I should have said it before, that there's a vertical asymptote at x equals -5. All right, because the equation, when I plug in -5, we listening over here, this group. All right, this equation, if I plug in -5, I get 0. All right, so again, rehashing, how do I graph a logarithm and what is it supposed to look like? All right, and then E is the base, so it should be increasing. So with ln graphs, we minimal had to know where the vertical asymptote was, x equals -5, and then that it increased. And then we would find that point by plugging in values. So plugging in 4 gave me -4, gave me 1 here. And anything raised to the 0 power equals 1. So this would become 0. All right. But anyway, that's just how that works. Okay, next one. Sure. We know, I feel like I skipped this one. I think I did. And you drop the logs. I'll show a better one than this. I don't think I have to do every single one. I did skip that one. Okay, real quick on this. This is good. First of all, what do I do first? All right, this is based off of yesterday now. What do I do first? Add 4. And in questions where I don't have to change a log to an exponent or an exponent to a log, your inequality keeps its balance here. So I can keep that as greater than. The other math teachers might be saying, change it to an equals, get x, and then do a number line test. But you don't have to do that on this one. Because what's 27? 3 to the what? Third. And I'm keeping my balance here. I'm keeping who's greater than who on the correct sides. All right. Then I can drop the 3's and then subtract 2. So I can expect x greater than 1 as an answer. I do want to see this, though, graphically, how I analyze that. So I'm going to graph this and this. First of all, that's y equals 23. So I'm going to have to extend my window. Number two, this should have a horizontal asymptote, and you should listen because this is going to be on your AP exam. You can't just forget everything. We spent a massive amount of time with graphing. This has a horizontal asymptote at y equals -4, and an input, say it. If I plugged in -2, -2 plus 2 is 0, 3 to the 0 is 1, 1 minus 4 is -3. I should expect that point. Graphing 101, the basics. We had you graph like more points, but whatever. So clear and clear. And I do have one more thing after this one, I believe, to cover. Whoops. All right. Whoops. Screwing up here left and right. There we go. 3 raised to the x plus 2 minus 4. 3 raised caret. I should be up here typing. No, I already forgot. What is it? X plus 2? Plus 2? Because I did say, oh boy, x plus 2. Watch the old guy struggle with technology. Then minus 4. And then what was the other side already? 23. All right. And then I'm trying to color code it with my pen here. Well, I already know my window is not going to be good enough. So 23 is the how high the y equals is. So I'm going to go past that, say y equals 30 for the max. Then I'll get that where that's located there. Okay, so I did get 1. So second, calculate. And I probably could have done this by hand, graphing to prove this, but I'll show the intersection one more time. Press enter, press enter, press enter. X equals 1 at 23. So that means when I plug in 1 into this one, I get 23 over here, which is greater than 23. Wait, how do I analyze this now? Okay, so this is what you have to think about. Input, say it. This is why I've said this all year long, right? And it makes me sad, people that still don't understand it. But this is the first time the blue outputs are higher than the red outputs. And that's how that solves. I do want to minimize that one more time. That's how that solves this inequality. The blue outputs, are greater than the red outputs after 1 on the x-axis. That's how you analyze an inequality with a graph there. It's a little different. So that should be enough because of input, say it. We've said it a billion times in this class. All right. And how many times that can actually help you. All right. I am going to do this algebraically. What's the first thing you do? Add 6. And I think this might be the last one because then with a logarithm, what do we do? Add 6, you get 2. Oh, and then this becomes easy. But here's where this gets to be problematic. When I change this logarithm to an exponent, now I don't know the relationship. Who's greater than who? Is 2 squared greater than x plus 8, or is x plus 8 greater than 2 squared? So this is where you need to do what I did yesterday. Change this to an equal sign, which is what I believe all the CAT teachers are doing with every question. All right. And then do a number line analysis, like input output, like I did yesterday in the notes, or you can look at the picture. But one or the other, you got to do something. Then this becomes x equals -4. But this is not correct yet. I got to get this as an inequality. What is a relationship? Is it greater than or is it less than? Okay. All right. So I showed you yesterday how we could figure that out. You could just plug in values and see when this side becomes bigger than that. It's usually greater than. I bet you greater than is going to be the results. But I'm going to go ahead and leave this over here, blue. And then those with I want all that in there. So I'll keep that -6 and then -4. Expectations, though, before I graph. The base is 2. So this graph will be increasing like this. Vertical asymptote at x equals -8. And then when I plug in -7, -7 plus 8 is 1. 2 to the 0 equals 1. 0 minus 6. I can expect the -6 as that y value when I plug in -7. Hopefully I didn't say that wrong. I'm kind of going fast there. But here we go. Pay attention. Clear. Okay, and I'm not teaching you this button. anymore. But here's this button for those that have the upgraded. So it's alpha window, not new. You have to type that, or you have to use the change of base in order to graph. I told you 10 years ago, this is what students had to do. They had to type this like this: log, it can either be log or ln, of the quantity x plus 8, watch up here, divided by log of 2. This is why in the bell work I covered the change of base formula yet again. So if you don't have that button because of your calculator, you must do that. Then minus 6. Right? Then I could do y equals -4 for the horizontal line. Then when I look at the pictures, here's what we got, and I'll expand in on this. This is good. And then what do I need? I need when the blues outputs are bigger than the reds. And when does that happen? To the right of -4. So it is x greater than -4. All right, so this is how the graphing calculator can help you solve a inequality. X is greater than -4. Okay, I probably could have done that by hand because this graph, it ended up being a nice number where they intersect, but we'll just leave it at that we could use the grapher. Okay, good. I think that's good enough. I look at your homework. Look at how that one I changed, the very last one. So I wanted a better question that kind of coincides with what I did here. I wanted it to look a little bit better. And then number 3 is a doozy. That's getting that in calculator ready form. If you can get 3 done correctly, you're in pretty good shape. All right, but I'll leave at that. See you later if I can get this closed fast, which is always an adventure. Where is that at? Oh, there it is. It's always hiding right there.